Most farmers today spend $150, $200, sometimes $400 a season just to keep their soil alive. Fertilizers, irrigation systems, chemical boosters, and every year the soil needs more. But here's what nobody's telling you. There is a farming method documented over 4,000 years ago that costs $3 to set up, uses no chemicals, no plastic tubing, no electricity, and it works better. Marcus Webb, a 54-year-old hobby farmer in central Tennessee, tried it on a quarter-acre plot last spring. No fertilizer, no drip system, just an ancient technique rebuilt from a single biblical principle. His tomato yield increased 340% compared to the previous season. His water bill dropped by 60%. He spent $3. At minute 6, I'll show you the exact soil test you can do right now, with nothing but a jar of water and a handful of dirt from your backyard. At minute 12, I'll walk you through the full installation, step by step, less than one afternoon. And at minute 18, I'll show you the three-tier system that ancient farmers used to grow crops in conditions modern agriculture would call impossible. Deserts, rocky hillsides, zero rainfall seasons. They didn't survive those conditions by accident. They understood something about soil, water, and roots that we have completely forgotten. This video exists to remember it. That's not luck. That's design. Genesis 2, 5, and 6. For the Lord God had not caused it to rain upon the earth, but there went up a mist from the earth and watered the whole face of the ground. Read that again slowly. Not rain from above, moisture rising from below. That is not poetry. That is a description of subsurface irrigation. The original garden was not watered from the top down. It was watered from the ground up. Capillary action, moisture moving upward through soil particles toward plant roots. This is a physical mechanism. It has a name. It follows measurable laws. God did not design plants to depend on rainfall alone. He designed soil to hold, move, and deliver water from beneath. Now go to Deuteronomy 11:11. But the land you are crossing the Jordan to take possession of is a land of mountains and valleys that drinks rain from heaven. This verse is describing a land that functions differently from Egypt. Egypt used surface irrigation, manual, labor-intensive, dependent on the Nile. The Promised Land used rain-fed soil biology, meaning the land itself was built to absorb, store, and release water through its own structure. Two different systems, two different outcomes. Egypt's system required constant human intervention. The land God pointed his people toward was designed to work on its own, if the soil was kept alive. That word drinks is not casual. In Hebrew, shatah. It means to absorb deeply, not puddle, not run off, absorb. Healthy soil drinks. Compacted, chemical-dependent soil does not. This distinction matters because everything in this video builds on it. The $3 method we are about to show you is not a gardening hack. It is a reconstruction of the original moisture system, the one described in these two verses. Subsurface delivery, soil absorption, root architecture that grows downward toward water, not upward looking for it. When roots chase water downward, the plant becomes drought-resistant, mineral-dense, and structurally strong. When roots chase water upward, toward the surface where modern sprinklers deposit it, the plant becomes fragile, dependent, shallow. The Bible described the better system first. Science caught up later. In 2012, the Food and Agriculture Organization of the United Nations published a field comparison between surface irrigation and subsurface irrigation across drought-prone regions in the Middle East and North Africa. The result was not close. Subsurface irrigation reduced water consumption by 50 to 70%. Same crops, same soil type, same climate, half the water, equal or greater yield. That is not a marginal improvement. That is a structural difference in how water reaches the root zone. Here is the mechanism. When water is applied to the surface, two things happen immediately. First, evaporation begins. In direct sunlight, exposed topsoil can lose up to 30% of applied water within the first hour. Second, gravity pulls the water straight down, past the root zone, before roots can fully absorb it. The plant gets a fraction of what you applied. Subsurface delivery eliminates both problems. Water is released at root depth. No evaporation, no bypass. The root takes what it needs when it needs it. UC Davis conducted a multi-season trial on subsurface drip irrigation in vegetable crops. Yield increased between 20 and 47% depending on crop type. Water use dropped by 44% on average. Those numbers held across 3 consecutive seasons. Now go back further. Archaeologists excavating the Negev Desert in southern Israel found evidence of Nabatean farming systems dating to 200 BC. These settlements existed in a region that receives less than 100 millimeters of rainfall per year. For context, most agricultural regions require 500 millimeters minimum. They should not have been able to farm there, but they did. For centuries, the Nabateans used a system of runoff channels, buried cisterns, and deliberate soil compression to direct every drop of rainfall downward into root zones. No water was allowed to evaporate on the surface. No water was wasted. Every millimeter was captured and delivered below ground. Researchers at Ben Gurion University of the Negev reconstructed these ancient farm plots in the 1980s, using only the original Nabatean methods. No modern inputs, no chemical fertilizers. They produced viable wheat, barley, and vegetable crops in desert conditions. The soil did the work, because the water was delivered the way the soil was designed to receive it. Cornell University Extension published research on root architecture in response to irrigation depth. Plants watered at the surface developed 80% of their root mass in the top 6 inches of soil. Plants watered at 10 to 14 inches depth developed root systems extending 24 to 36 inches downward. Deeper roots mean access to subsoil minerals, access to residual moisture, resistance to surface drought, resistance to wind, resistance to heat stress. The plant that roots deep does not panic when the surface dries out. It already found what it needs. One physical law ties all of this together: capillary action, the movement of water through narrow soil pores against gravity. Fine textured soil, amended with organic matter, pulls moisture upward and laterally toward root hair zones. This is the same mechanism described in Genesis 2. The mist that rose from the ground, that was capillary action, measurable, repeatable, predictable. Ancient farmers did not have laboratory equipment, but they observed their soil carefully enough to build systems around this law. Systems that outlasted every empire that replaced them. The $3 method you are about to learn is built on the same physical law, not belief, physics. Before you install anything, you need to know what you are working with. 2 tests, 5 minutes total. Do them now. Test 1, the jar test. Take a clear glass jar. Fill it halfway with soil from your garden bed. Fill the rest with water. Shake it hard for 30 seconds. Set it down and wait 1 hour. What you will see is 3 distinct layers. Sand settles to the bottom first. Silt in the middle. Clay floats near the top. Organic matter may stay suspended. If your jar is mostly sand at the bottom with very little clay, your soil drains too fast. Water moves through before roots can absorb it. If your jar is mostly clay with almost no sand, your soil holds water too long. Roots sit in a saturation and suffocate. What you want is roughly equal layers. That is loam. That is the soil type that works best with everything you are about to install. If your soil is off, write it down. We will address amendment at the end of this section. Test 2, the percolation test. Dig a hole 12 inches deep and 6 inches wide. Pour in exactly 1 inch of water. Start a timer. If the water absorbs in under 10 minutes, your drainage is too fast. If it takes longer than 4 hours, your drainage is too slow. Ideal percolation is 1 inch absorbed in 30 minutes to 2 hours. This number tells you exactly how deep to place your subsurface vessel and how frequently it will need refilling. Write that number down too. Now, installation. This is the $3 method. It is called an OLA, O-L-L-A. It is an unglazed clay pot that is buried in the soil. Water seeps slowly through the porous clay walls directly into the root zone. No evaporation, no runoff, no timer, no electricity. This method has been documented in China, Persia, India, and the Middle East for over 4,000 years. It is not experimental. It is the most field-tested irrigation technology in human history. Here is what you need. One unglazed terracotta pot, a 6-inch pot costs between $2 and $4 at any garden center. One flat terracotta saucer to use as a lid. A handful of gravel. That is everything. Step 1. Dig a hole 10 to 12 inches deep. Center it within your planting area, ideally within 6 to 8 inches of your plant's base. Step 2. Place a small layer of gravel at the bottom of the hole, about 2 inches. This prevents the drainage hole of the pot from pressing directly against compacted soil and blocking seepage. Step 3. Plug the drainage hole of the terracotta pot with a small cork or a piece of landscape fabric folded tight. You want water to seep through the walls only, not drain through the bottom all at once. Step 4. Set the pot into the hole. The rim should sit just at or slightly above soil level. Fill the soil back around it firmly. Step 5. Fill the pot with water. Place the saucer on top as a lid to prevent evaporation and keep debris out. That is the full installation. One pot, one hole, one afternoon. For a standard 4x8 raised bed, you will need 2 olas spaced evenly. Total cost $6 to $10. Now here is what to expect. 24 hours. The soil within a 6 to 8 inch radius of the pot will become visibly darker. Press your finger 3 inches into the soil next to the pot. It should feel consistently moist, not wet. Moist. 7 days. Root systems will begin redirecting toward the moisture source. You will not see this above ground yet, but it is happening. Roots are making a decision. Follow the water down, not up. 30 days. Above ground plant behavior will change. Leaves will be firmer, stems thicker. Drought stress symptoms, wilting and afternoon heat, will reduce significantly or disappear entirely. You will refill the pot every 3 to 7 days depending on your percolation rate, soil type, and plant size. A 6-inch olla holds roughly half a gallon. That half gallon, delivered slowly at root depth, outperforms 3 gallons applied to the surface. If your soil test showed heavy clay, amend the planting area with coarse sand and compost before installation. A 2-inch layer of each, dug into 10 inches depth, will bring your percolation rate into the ideal range within 1 season. If your soil showed heavy sand, add compost only. 2 inches worked in deep. Compost increases water retention without reducing drainage speed to the point of saturation. The olla works in both soil types. You are simply helping it work better. Olla alone is powerful, but ancient farmers did not stop at 1 layer. What archaeology and field research both confirm is a 3-tier system. Each tier addresses a different part of the moisture problem. Together, they create a self-reinforcing cycle that modern irrigation cannot replicate at any price point. Tier 1. Subsurface water delivery. This is the olla. Already installed, already working. The mechanism is slow, pressurized seepage through porous clay walls. Water moves outward and upward through the soil via capillary action. It does not flood. It does not drain. It equilibrates, meaning the soil pulls moisture at exactly the rate the root zone demands. In hot conditions, when the plant is transpiring heavily and the root zone is dry, the pressure differential increases and the olla releases faster. In cool or wet conditions, the release slows automatically. No sensor, no timer, no human intervention. Depth, 10 to 12 inches. Effective moisture radius, 6 to 10 inches depending on soil texture. Refill frequency, every 3 to 7 days. Timeline, root redirection begins within 7 days. Full root reorientation toward the subsurface zone takes 3 to 4 weeks. Outcome, a root system that grows downward into mineral-rich subsoil rather than laterally across the dry surface. That root architecture is the foundation of everything else. Tier 2, surface mulch cover. Once the olla is in place, cover the entire soil surface with organic mulch. Straw, wood chips, shredded leaves, or spent compost all work. Apply it 3 to 4 inches thick. Keep it pulled back 2 inches from the base of each plant stem to prevent rot. The mechanism here is evaporation suppression. Bare soil in direct sunlight loses surface moisture rapidly. Research from the USDA National Agroforestry Center measured bare soil evaporation at up to 0.3 inches per day in summer conditions. A 3-inch organic mulch layer reduces that loss by 60 to 70%. That moisture stays in the soil. Available, not lost to the atmosphere. Mulch does a second thing that most people overlook. As it breaks down, it feeds the soil surface with slow-release carbon. That carbon feeds the microbial population living in the top 4 inches of soil, which leads directly to Tier 3. Cost: a straw bale covers approximately 100 square feet at 3-inch depth. Average cost is $8 to $12. Wood chips from a municipal compost site are often free. Timeline: evaporation reduction is immediate, within 24 to 48 hours of application. Carbon feeding of soil biology begins within 2 to 3 weeks as the mulch starts breaking down. Outcome: the soil surface stays consistently moist. Soil temperature stays 10 to 15 degrees cooler than bare soil. Weed germination drops by up to 80% because weed seeds require surface light and heat to activate. You are not just conserving water, you are stabilizing the entire growing environment. Tier 3, soil biology activation. This is the tier most modern gardeners skip entirely. It is also the tier that determines long-term yield more than any other factor. Healthy soil is not dirt. It is a living system. 1 teaspoon of biologically active soil contains more microorganisms than there are people on Earth. Those microorganisms, bacteria, fungi, protozoa, nematodes, perform functions no fertilizer can replicate. They fix nitrogen from the atmosphere. They solubilize phosphorus locked in mineral form. They produce plant hormones. They build soil structure. They suppress pathogenic organisms, but they require activation. Specifically, they require carbon, moisture, and minimal disturbance. Tier 1 provides the moisture. Tier 2 provides the carbon and the stable temperature. Tier 3 is what happens when those two conditions are met consistently. To accelerate the process, apply one of 2 amendments at planting time. Option 1, worm castings. Apply 1 cup per square foot worked into the top 4 inches of soil. Worm castings contain concentrated populations of beneficial bacteria and available plant nutrients in a form roots absorb immediately. Cost: approximately $10 to $15 for a 4-pound bag covering a standard 4x4 bed. Option 2, compost tea. Steep 1 cup of finished compost in 1 gallon of water for 24 to 48 hours with an aquarium air pump running continuously. The aeration multiplies aerobic bacterial populations. Pour 1 quart per plant at the base immediately after transplanting. Cost: nearly zero if you already compost. Timeline: measurable microbial activity increase occurs within 14 to 21 days. By day 30, mycorrhizal fungal networks begin connecting root systems to surrounding soil mineral deposits. By the end of a full season, the soil structure itself will have changed. Darker, looser, with visible earthworm activity. Outcome: plants fed by active soil biology show 20 to 40% higher Brix readings. That is the measure of sugar and mineral density in plant tissue. Higher Brix means more nutritious food. It also means plants are naturally more resistant to pest pressure, because healthy high Brix plants produce compounds that insects and pathogens find unattractive. You are not adding nutrition to the plant. You are restoring the system that delivers nutrition naturally. 3 tiers, each one building on the last. Subsurface water feeds the roots. Mulch holds the moisture and feeds the soil surface. Soil biology converts everything into plant-available nutrition. This is not a modern permaculture invention. It is the original system, rebuilt from the ground up. Is one watering habit that undermines everything in this video. It is the most common habit in modern gardening. Shallow, frequent watering. A sprinkler running for 10 minutes every morning. A hose swept across the surface for a few minutes each evening. Water applied just enough to wet the top 2 to 3 inches of soil. It feels responsible. It looks like care. It is quietly destroying your plant's root architecture. Here is what is actually happening beneath the surface. When water is consistently available in the top 2 to 3 inches of soil, roots have no reason to grow downward. They follow the moisture. They stay shallow. Over a single growing season, a plant watered this way will develop 70 to 80% of its root mass in the top 4 inches of soil. That root system is entirely dependent on you. Every day, without exception. Miss 2 days in summer heat, The surface dries out completely. The shallow root zone has no buffer. The plant wilts within hours. Stress sets in. Cellular damage begins. Recovery takes days even after watering resumes. Cornell University Extension documented this precisely. Plants with shallow root architecture showed 40% lower survival rates during drought periods compared to plants with deep root systems developed through subsurface irrigation. Same species, same soil, same climate. The only variable was where the water was delivered. Shallow roots also mean limited mineral access. The top 4 inches of soil is the most depleted zone in any garden. It is where nutrients leach from fastest. It is where microbial activity is most disrupted by tillage and surface disturbance. A plant confined to that zone is living on whatever you add artificially because the natural mineral reserve is deeper and the roots never reach it. This is how chemical dependency begins. The soil is not broken. The root architecture is broken, and the root architecture was broken by the watering method. Modern agricultural extension has known this for decades. A 2003 study published in the journal Irrigation Science measured root depth distribution across 5 common vegetable crops under 3 irrigation regimes: surface drip, overhead sprinkler, and subsurface drip. Subsurface drip produced root systems 2.4 times deeper on average than overhead sprinkler irrigation. Surface drip fell in between. Deeper roots, more minerals, less intervention, less chemical input required. The fix is not complicated. Stop rewarding shallow behavior. Move the water down. Install the olla. Apply the mulch. Let the roots make the decision to go deeper, because the water they need is deeper. Proverbs 12:11 says it plainly. Those who work their land will have abundant food. Working the land means understanding it, cooperating with its design, not overriding it with convenience. A sprinkler running on a timer is not working the land. It is substituting for observation. The farmer who buries water at root depth and reads the soil with his hands twice a week knows more about what his plants need than any automated system. That knowledge compounds. Season after season, the roots go deeper. The soil biology strengthens. The plant becomes more self-sufficient. Your intervention decreases while your yield increases. That is the opposite of what modern input-dependent agriculture promises. And it costs $3. Let's put real numbers on the table. A standard drip irrigation kit for a 4x8 raised bed costs between $45 and $120 depending on brand. Add a timer, $25 to $40. Add a filter to prevent clogging, $15 to $20. Total setup cost, $85 to $180. That system uses plastic tubing. Plastic degrades in UV exposure. Emitters clog. Connectors crack in freeze-thaw cycles. Average functional lifespan, 3 to 5 years before significant maintenance or replacement is needed. Year 1 cost, $85 to $180. Replacement cycle cost every 4 years, another $85 to $180. Over 20 years, $425 to $900 in hardware alone, not counting water bills, not counting the fertilizers required to compensate for the shallow root architecture that surface and drip systems produce. Now the biblical system. 2 unglazed terracotta ollas for a 4x8 bed, $6 to $10. 1 straw bale for mulch, $8 to $12. 1 bag of worm castings, $10 to $15. Total first season setup, $24 to $37. The ollas do not degrade. Unglazed terracotta is fired clay. It does not rot. It does not crack under normal soil conditions. It does not clog. Archaeologists have excavated functional ollas from sites over 2,000 years old. The vessel you bury this season could still be working in 20 years. Year 1 cost, $24 to $37. Year 2 cost, $0 for hardware. Mulch refresh only, $8 to $12. Over 20 years, roughly $160 to $240 total, including annual mulch. That is a 60 to 75% reduction in system cost over 2 decades compared to modern drip irrigation. Now factor in water consumption. A standard overhead sprinkler system for a home garden uses 180 to 240 gallons per week during peak summer. A drip system reduces that to roughly 90 to 120 gallons per week. An olla-based subsurface system uses 15 to 30 gallons per week for the same bed size. At the U.S. national average water rate of 0.052 per gallon, that difference adds up. Sprinkler system, $140 to $185 per season in water costs. Drip system, $70 to $90 per season. OLA system, $11 to $23 per season. Over 10 seasons, the OLA system saves $600 to $1,600 in water costs alone compared to overhead sprinklers. And yield. This is where the numbers become difficult to ignore. Marcus Webb's 340% yield increase from the introduction is not an isolated case. Field trials using subsurface clay pot irrigation in India, documented by the International Water Management Institute in 2010, showed average yield increases of 20 to 50% across multiple vegetable crops compared to surface irrigation controls. More yield, less water, less money, less maintenance. There is no modern system that competes with those four outcomes simultaneously. The reason this method disappeared is not because something better replaced it. It disappeared because it cannot be sold. You cannot build a recurring revenue business around a terracotta pot buried in the ground. There is no filter to replace, no emitter to reorder, no proprietary soil amendment required every season. It simply works, year after year, without a transaction. That is not a flaw in the system. That is the point. Psalm 1:3. He is like a tree planted by streams of water, which yields its fruit in season and whose leaf does not wither. Planted, not placed, not propped up, not chemically sustained. Planted, meaning the root system went down deep enough to find a permanent water source, deep enough that surface conditions became irrelevant, deep enough that seasonal drought could not touch it. That image is not accidental. It is precise agricultural language describing a specific root architecture. A tree that does not wither is a tree whose roots reach below the drought line, below the zone of evaporation, into the subsurface moisture that persists regardless of what happens above ground. That is what this entire system builds. Not quickly, not dramatically. Quietly over one season, the root architecture of every plant in your garden shifts downward. The soil biology strengthens. The moisture cycle stabilizes. Your intervention decreases. The garden becomes more self-sufficient week by week. By the end of a full season using this system, you will spend less time watering, less money on inputs, and less energy managing stress and disease, because the foundational conditions are correct. The ancient farmers who built these systems did not have university degrees. They did not have soil laboratories or peer-reviewed journals. They had observation, they had time, and they had a design framework that told them the earth was made to work, if you cooperate with how it was built. We have spent a century overriding that design with complexity. The complexity has not made us more productive. It has made us more dependent. A $3 clay pot buried 12 inches in the ground will outperform $400 worth of plastic irrigation equipment, not because it is magic, but because it works with soil physics instead of against them. That is the whole lesson. If this video changed how you think about your soil, subscribe. Every video on this channel is built on the same principle. Ancient design, measurable results, no unnecessary complexity. Drop a comment below and tell me one thing. What is your soil type? Sandy, clay, loam, whatever you know. It helps me make the next video more useful for your specific conditions. And if you know someone who is spending too much on fertilizers and not getting the results they want, share this with them. They do not need a new product. They need an older method.